Okay, so before the break, we were kind of going over how we've seen all the parts we need to make software. We've seen them in small segments, but now it's time to put them all together. That's the main caption on today's notes, is tying it all together. So we're ready for our first example. Kind of set up this little problem here. A small company that I have 5 or 6 sites around the region, and the IT guy needs a list of networking addresses. We'll just use IP version 4 addresses for those who have seen them. For those who haven't had the networking class yet, we just need 4 random numbers, almost random. We might make them not so random. The first 2 shouldn't really be random, but we might do 4 random ones. And we connect them together as with a dot or a period is how we're used to saying that as we move from English into IT stuff. But going through IT, we usually just say dot because that symbol means things. We actually call it the dot operator. So it gets categorized with the plus sign and the minus and multiply and our math operations, because a period or a dot usually does stuff. So we'll generate 4 random numbers to do that. So that part's the easy part, but going over the planning steps, because well, we've talked about this before. Anything that fits in the time constraints of a classroom is something you could probably just immediately sit down and do without a plan. But when you get out, after you pass the classroom scenario and you're out there in the real world working on really, really big problems, you don't want to learn to make a plan when you need that plan. So turning that around, anything that fits in the time constraints of a classroom is going to be really easy to make a plan for. So you can get some practice with making plans here. In particular, 2 big numbers people are going to care about in the real world that are always as trivial as can be in a classroom. So here's the problem. Our goal is to solve this problem. Make some software for this IT guy that prints out some numbers. But when you get out and start turning in project proposals to managers and clients, they're going to want to know what the budget for the project is and what the timeline for it is. And for us here in a classroom, the budget's always going to be 0, as trivial as can be, and timelines by end of class. I'm going to put 45 minutes here. It's just my rough estimate on how long that's going to take. But in a classroom, you can also make up some numbers to put there. Based off the timeline, take an estimate. You've done a little bit of programming now, seen a few things, so you can probably start making educated guesses about how long it's going to take you to put a program together. Then make up some number to charge for that amount of time. And after you get the program together, come back and check how accurate your estimate was, because if you can be good at predicting those 2 numbers, clients and managers are going to be very, very happy about that. People will take notice, and it will that will definitely pay off. And it's just random practice that's easy to work into your classroom stuff. So that's what we're going to do. So the plan for this, I'm going to draw up here in picture form. We did word form last time. We've seen a little bit more about UML diagrams now. So I'm going to start with the overall plan. So we have our actor, the user, and then what the software does. And we're going to do what's called menu-driven programming. So to keep the software running, we'll make our software menu-driven, where when we show that prompt to the user and ask for input, there's going to be a list of options. Things like press 1 to add another site, press 2 to view all of your sites, and press X to exit, that sort of thing. We'll probably just use a couple words because I only have a couple things in mind. So our options will be to That's probably way too small to see in the picture there. Let me write that a little bit bigger. We could configure a new site. So that'll be one of the options from the menu. Or we could view one of our sites, another one of our options, or exit. In a full piece of software, we probably want a little bit more, but we are under tight time constraints for Classroom. So our user will interact with our menu, and the software can do one of these three things. Add a new site with a bunch of machines to it, and a list of IP addresses for the machines at that site. We can pull up one of our sites and see the list of IP addresses assigned to all the machines at that site, so we can track down problems and work with those, remotely access them, configure, set them up, and attach them to our network and recognize them and all those things. Or we could go ahead and shut down gracefully because the user is finished working with our software. So we have multiple options, and the software will keep running until the user chooses that exit option. Then I drew some pictures here. So for our config option, basically we'll ask the user for a name. I should write the word first, that way it's big enough to see. Ask the user for a name, and I'm just going to put that in an input box. Right, this is planning. This is the part that gets messy. But it's easy to practice this stuff in a classroom to figure out what works best for you as far as making plans. That way, when after you graduate and you have a really big problem to solve, you know how to make a plan and can start working on that. The thing I always like to refer to is in Hollywood, something we often see spoofed in movies, is a writer sitting there in a room that's just covered with wadded up pieces of paper, right? All the ideas that they jotted down and then discarded and just kept trying things. That's an important step. Don't skip it. So when we configure something, we'll get a name from the user. Then we'll get the number of machines. And then we'll add those into our long-term storage so we can come back and get them. And when we need to view one, it'll basically be the other way. The computer will go over to long-term storage, grab some stuff from there, and output it to the user. So using pictures this time instead of words to kind of put that rough idea together, watch the flow of it. Seen a couple different types of diagrams. I guess this would be an activity diagram. We have the activity of asking the user for the name of the site. And that after that's the activity of asking the user for how many machines there are, then the activity of writing that to storage. And when we want to view one, we have the activity of grabbing stuff from long-term storage, and then the activity of outputting that to the user. A few other details we could work in along the way. We probably need some loops, right? I'll grab a colored chalk and come back here. So like this arrow, I'm going to write sideways to help accentuate. The planning part's going to get messy. Right? This is all the wadded up pieces of paper that get thrown away, things scribbled out, written on top of. It's putting our ideas together. And then once we get the idea together and know what we're going to do, then typing is just tedious, busy work at the end. Loop number of times. Oops. And when we get over in file, we need to store this somewhere. but we have the name of the user. So I'm gonna take that name and we'll store that using the name of the site. So site name, name's kind of vague, so I'll come over here and change this variable, call it site name. Then it's more explicit and clear what that's referring to. That'd also be a good file name to keep track of all of these machines. So we'll put this in a file over in long-term storage called site name.txt. Hopefully that's enough to kind of get the general idea there, right? The messy steps to the scribbling things out and going back and forth until you have a nice plan worked out, you know exactly what you're going to do. And then you can come over to the computer and start putting it together. So I guess a couple things to add on here. So our overall, our menu, the menu driven part here, that needs to be one big loop so that it keeps going. We do something, then we come back around, do something else. Come back around, do something else, and keep coming back around until the user's done. So we have I'll list that as a main loop. And then these other ones, configuration and view, that'll go into a selection structure inside of our main loop. And then the exit, well, that'll just be the condition to leave main loop. Leave main loop. So a bunch of messy notes. I like to do the plans different ways because they kind of mean the same thing. And I think everybody usually coming into this class has a basic idea of what it would mean if I were to just said, make a plan at the beginning. So going through some examples, the pictures can be nice, help us see the flow of things. And this is only for your benefit, so it doesn't have to be super nicely organized. Just a way to collect your thoughts. So looks like we need one great big main loop to we'll enter a menu for, and one of those options is going to be exit, or we'll have two other options that we go into that loop for. And then once we're in that loop, we'll select between those two options and maybe have an extra branch to be like, okay, that's bad input if they give us something other than configuration or view. And then we'll just run through whichever option the user chose, come back around and ask them, what do they want to do next? Over and over and over again. That's sort of the plan here. So does anybody have any questions about the general plan on what this software is going to do? And then that'll provide the IT guys with list of the network addresses at each site. Okay, I assume the silence means no questions. And this is actually a very common piece of software. It's built into most of your network, most any network control stuff that you use already has this sort of program built into it. But we'll go through sort of the process of it and see a finished example. I have an example here on my Chromebook pulled up. So you can see it's, I have it printed out as a PDF. So I will probably send you that PDF after class, but it's often a good idea to follow along. I'm trying to go to speed, make sure we're all following along. So if you follow along, as you're following along, if you have any questions or need me to slow down or something, just let me know. So now, after all that planning, we've got our basic idea together, so we can just start implementing. Dragging pictures around, but typing fits better in a sentence. So now that our plan's together, it's time for the tedious, busy work of putting that plan into action. So overall, we need our main loop. the thing that's going to kind of control everything. So I'm bringing in loop structure, and it's menu driven. So this is our main loop. I'll go ahead and add a comment to label it main loop. So this is what we want to keep going over and over again. And we'll do that based off the option the user gives us. So also on menu driven stuff, having that set up as a post test as far as the input goes, it makes kind of a nice thing. Because we'll get some input and then we'll check what that input is. So the prompts, just like we've seen before for input, but we want to be very specific. Make sure it's clear to the user what to do and what they need to enter. So like, what do you want to do next? Enter config. Oh yeah, I made a typo, but I'm going to go with that typo and we'll look at the error message. I like to look at error messages and go over how to fix them instead of just avoiding them in class. But we'll see that here in a second. Enter config to configure a site, a new site. Enter view to see a site, or enter exit to leave. So there's our overall prompt, and then we'll say user choice. I'll call that the user's choice. Oh, so there's that little error message. So I want to quote marks, right? So this is the option that I'm going to have them type in. Could do something like enter 1 to configure the site, enter 2 to view the site, or enter exit to leave. However, you go ahead and go with the words. That way it's very clear what it should be. But the problem is those quote marks. So when we open the quote marks here, it reads through there, and then I want to put quote marks specifically around this word. So it tried to put, but when we hit that first quotation mark, it closes our opening quote mark here. So it's saying that's the end of the string. And then there's more stuff. So the computer got confused on what to do next. It's like, well, the only thing I can do after the end of the string is the plus sign and add more stuff to it. So there's a couple options. One of them is most directly, we can concatenate in this function to ASCII and then which ASCII character do we want? Which probably don't have memorized, so we can go Google that. I'll put up one of these ASCII for quote marks. (0x22). So when you see 0x22, that's in hexadecimal. So what is that? That's so 2 in the 16 columns. So anytime you see 0x, that means we're looking at a hexadecimal number. So we have 2 in the 16 columns. So 2 times 16 is 32, plus 2 in the ones column. So we need ASCII character 34 would add those in. Do we have escape sequences here? I don't think we have escape sequences. In a lot of languages, we can use a backslash, and that means escape out of the code, because quote marks mean something to the programming language. So we have to leave the programming language and actually put a quote mark there. I don't think we have those here. I can't tell exactly where that error is happening at. So I'll just do this everywhere. So any place I want to add quote marks. Let me see if the escape sequences work. That might be an easier way. So we can directly put that in as say we want this ASCII character. Backslashes. Oops. Documents, delete. I'll just call this netty. Okay, so we do have backslashes. So instead of doing that character directly, because that's kind of a lot to keep track of, we can put a backslash right before it. And that's saying escape out of the coding symbols and actually put a quotation mark. So we call those escape sequences. They're available in pretty much all our languages. Another alternative in this case would have been to use a single quote mark instead of a double quote mark. If you can see that on my screen, it's really small, the apostrophe instead of quotation marks.
That's what my brain defaulted to, was the apostrophes.
Yeah, that would work. That won't always work though. So in Raptor's written in Perl here. So in Perl, as well as in Python, double quotation marks and single quotation marks are interchangeable, but they're not always interchangeable. Actually, they're not interchangeable in more languages than they are.
It seems like they could be used for different operations.
Yes, usually a single quote mark is for a single character. Double quote marks are for an entire string.
That makes sense.
So if we're in an open type language that does not distinguish between the two, then they're interchangeable. But more of our languages do make that hard distinction between them. And the other problem with that is we can only go one layer deep. Right? We only have two symbols, so we can only put single quote marks instead of double quote marks, or double quote marks instead of singles. So generally the escape sequence is better to do that. Anytime you actually want to type a symbol that means something to the programming language, you have to escape out of the language, type that symbol, and then come back to it. That way you're not accidentally telling the machine to do something. So when we run this, oh, I can't run it yet. Well, I can go ahead and put the exit condition in. So we know that when user choice is equal to the word exit, that means the user is ready to leave. And you always want to run a test every chance you get. We're the place we can test. We can see if the leaving works and just print out, give a nice little printout. Thank you, have a nice day. Some sort of message so we can tell we're done. And I guess we should probably do this default clear the console. Really, we want to do that every time. I think we've seen that before. So we'll clear anything out of our console. That way we have a fresh slate to start with every time. We'll show the user this prompt. And then we have escape sequences. So we'll have those things we actually want the user to enter explicitly in quote marks to help make that clear. And if they type in the word exit, then we'll know we're done, so we can go ahead and leave. So we can run a test on that. So you can see the escape sequences, which are exactly the same in Python. If you need to actually put a quotation mark in your string, just put a backslash right before it. What do you want to do? Enter config to configure a new site. Well, we don't have that option yet. View to see a site, or enter exit to leave. And notice here in Raptor, our input prompt box, we can't change the size of that. That was already pre-built. So when you do menu-driven programming, you might have to rephrase it a couple times to make it fit. When I was doing that this morning, the first message I came up with actually didn't fit in that box. I was like, whoops. So I had to come back and make do some adjustments and yeah, we can only fit 3 lines in that box. So you might have to make slight adjustments to your prompt to make sure it works. I guess the only thing we can test so far is exit. And really, there's a problem here we might want to address. I'll just point it out. But what if the user types that? Will that get us out of our program?
No.
No, 'cause-
No, it's like I remember doing that the thing in the selection tool, but then it said yes or no, and I
Yeah,
put
so-
no, and then it still went on.
Yeah, so really on this, we would need to check if a user choice is equal to all capital exit, or, and I'm doing 2 pipe symbols, the vertical line right above the enter key, right above the back shift and backslash. Is it all caps or is it a capital E? And we'd really want to check for every way they can type it. But to keep from our example from getting too cluttered, I'm just going to leave everything lowercase now. But please keep that in mind, especially for your projects, that you'll want that or condition. Exit or exit in all caps or exit with a capital E. There's some other alternatives that could be there, but they're probably not going to capitalize anything, but it's either going to be the first letter or all caps or no caps, just because of the way we type things. But a lot of different ones that you might want to keep in mind would actually need checked for. So we have a way to leave our main loop, but we want to do some stuff inside of our main loop. So, and there's multiple options, because if they didn't type exit, then we need to know if they type config. So inside of our main loop, we'll stick in a selection structure and see if they type config. If they didn't enter exit, then did they enter config? Because, well, the only way we'd get here is if this one's false, right? Because if they entered yes, we're leaving and we'll never hit this block. So they didn't type exit, so maybe they entered config. If they didn't enter config, did they enter view? Does user choice equal view? And notice we are comparing strings exactly. What the user types is coming from the keyboard, which means it's coming in as a string of characters. So we want to make sure and put our quote marks around it. And well, that's where our choices here end. Your projects are probably going to have some more interesting choices, but if it's not one of those 3, then they gave us some bad input. So I'm going to say invalid. I'll print out the message, invalid input. And I think I'll go ahead and add a delay in here. Delay for 1.5 seconds. So that's pre-built. We can just pause for a moment. So we'll print out the message invalid input and then wait for like a second and a half to make sure the user gets time to read that message says invalid input. Then it'll come back around and we're in our main loop. So it just comes back around and asks again. And we can run a test on that. And you want to run a test every chance you get. I guess there's the only thing we can really, well, if we enter config, it's not exit, so it goes through there, but the config branch doesn't do anything. So it kind of came back around. It didn't go to this one, so it had to have gone this way. User could enter view, not config, so it went there. It didn't go down this branch, so it had to have gone this way, although we don't see anything yet. We can quickly deduce that that's the direction it went. Or they could type bad input, right? Give us some sort of bad input. It's not exit, it's not config. Oh, invalid input, and pause long enough till they see that message. And then exit still works. So that's sort of a menu-driven main loop. That's the one that goes back to console days before buttons. And hopefully you can already see how that would escalate to the button thing, right? Instead of typing in a specific word, we give them a particular little box on the screen to click on. And if they click on that, it's the same as one of these typing in words. So menu driven is still kind of the old style, but when you're working in the console, that's what console sort of software would work with, using menu driven options. And then hopefully you can see that that's an easy expansion to turn that menu into specific spots on the screen to click on. And that's where that's the core idea behind GUIs. And then one of those spots on the screen, usually a little a picture of an X up in the corner, or on a Mac is a picture of an X inside a circle over on the other side. But one of those spots the user can click on the screen is the exit option that leaves the main loop for the software. So that's why I'm always excited about this day. It's like we're finally up to a full piece of software that will keep running until the user types in the word exit for our case here. So now we need to do stuff now we need to fill in these branches. I have this on a PDF, but I could send it to you. Well, we'll just talk about what happens. So if they want to configure a site, there's a couple things we need to know. We need to know what site is it. So I was just going to go with some sort of reference name, like the city it's in, and how many machines are there. And then we can generate a bunch of random IP addresses to assign to all of those machines. So we'll need some input from the user. What did I put in my example? Enter the name of the site. So we'll ask for a name of the site, and I'll just call that site name, which that's what's on the board. Oh yeah, that is on the board. Here's what we have to do on this branch. We'll ask the user for the site name, ask the user how many machines there are, then we'll open a file or create a file with the name of that site. Then we'll loop through a bunch of times, however many machines there are, and generate a random number and put a random number in that file each time through. So that's what we need to do in this first branch. So we'll grab site name, and then we'll ask how many machines are there. How many computers and are there? And that will be number of machines. That one didn't make it in the planning phase earlier. Until last fall, this class always required turning in algorithms with your programs, like written out pseudocode and things. And I always like to point out to people that I could always tell when the plan was done after the program, because when the plans are done first, the program never matches. But when the program was done and the plan was done afterwards, just to meet that criteria, they were always an exact match. But between the planning phase and the actual coding it up, little changes always happen. So I was always able to tell immediately whether the algorithm that was turned in was written before or after the program. Not that it makes much of a difference, but things change from the plan. That's the messy gathering your thoughts, collecting all your ideas. All right, so there's our numbers. So now we need to loop through and write that to a file. So I'm going to redirect the output to the file. So redirect output. And earlier we put in yes when we did that example, and it opened up the normal browse to box. But this time I know exactly what I want that file to be named. In order to keep everything straight, I'm just going to give that file the name of the site. So whatever the user entered, but then we need to tack on an extension. So like .txt to say it's a text file. So the site name, so if they say Sellersburg, we say sellersburg.txt is the name of our file. Or they say Jeffersonville, it's jeffersonville.txt is the name of that particular site. So we're going to send everything there and just loop through a whole bunch of times. And before we get to what actually happens in the loop, I'm going to set up the loop, set up all the conditions for the loop. Because it's really easy to enter infinite loops when we're basing things off like counters, right? We have the number of machines. So it's really easy to do all the hard thinking stuff and get our mind in that frame for thinking about all the stuff that needs to happen through the loop, and then forget that trivial case of incrementing our counter or decrementing our counter, because we know how many there are in total. So we'll just go until that's down to 0, until number of machines is less than or equal to 0. So if there's any positive number of machines left, we'll go through and decrement the number, set number of machines, number of machines to whatever was in that variable minus 1. So we'll decrement it. So like if the user says there are 5 machines, I get down here, 5 is bigger than 0. So we'll do some stuff, and then that drops down to 4. 4 is bigger than 0. Do some stuff, drop that down to 3. And then keep going around 2, 1. And finally, that's going to reach 0. And then we're done with our loop and can just go ahead and move on to other stuff. And the first thing we want to do when we move on is close that file. We want to redirect output to no. So those aren't actually, those are just housekeeping sort of steps, right? That's what we have to do just to run a loop, what we have to do to open a file, and remembering to close the file is absolutely critical, because I'm sure everybody here has at some point gone to do something and like your cursor wasn't where you thought it was. You were ended up typing in the wrong spot. We're intelligent. We will notice that immediately. But if we left this file open, whatever we tell the computer to do next, it's going to keep doing in that file because we already told it to go work in that other file. And it will never notice it, which in our case wouldn't hurt anything, but you can probably very easily see how that could be destructive to your machine if you accidentally start working in the wrong file and the computer does a whole bunch of stuff in some critical file somewhere. It could very quickly turn destructive. So every time you open a file, make sure you close it. And then this is just housekeeping for the loop. We have enough counter-controlled loop. It's one of the vocab terms in the book homework this week, the vocabulary for how we talk about and describe loops. It's counter-controlled, so we need to make sure that our counter does get adjusted every pass of the loop so that we eventually hit that control value where we exit. And then on each pass, we need an IP address, which let me pull that back up. That one, any IP address, I'll use Ivy Learn again. ivylearn.ivytech.edu. So an IP version 4 address looks like this. It's four numbers tied together with a dot operator. There are multiple alternatives. We can access more than one server holds the Ivy Learn site, right? There's lots and lots of people that need to get to that site. So we don't want anybody to have to wait because the server's bogged down. So several thousand servers with several thousand sockets each are available. So it sent me over to the ones in Virginia. There's three of them sitting there in three servers sitting there in Northern Virginia that can probably handle up to 10, 20,000 people at a time, which would handle most of the people that need access to it. But we need an IP address. We need four numbers tied together with a dot operator. And we've seen how to generate random numbers. So I'm just going to call them first, second, third, and fourth. So we need a random number. And again, to recap, when we just say random, that gives us a number between 0 and 1 that includes 0 but not 1. So a fraction of the way between 0 and 1. IP addresses are 8-bit things. Each of the numbers are 8 bits, so we can go from 0 to 255. So we can hold 256 values. So to make that bigger, we'll multiply by 256. So that gives us a number between 0 and 259.9999999, however many nines the computer till the computer runs out of bits for the 0.9s. So right below 256, because that original one didn't include 1. So when we multiply, we don't include that upper bound. But we only need the integer portion. So now I'm going to wrap that in parentheses and add in the floor instruction right before it. So get a random number between 0 and 256, not including 256, so that when we cut off all that fractional part, we get a random integer between 0 and 255. And that will be all our parts. We just need different names for them. Second, third, and fourth. And when you're coding, try to think ahead a little bit and copy and paste as much as possible, because humans make typos, not machines. So when you get one line working right, you want to copy and paste that so that the computer does the typing for you. Does what we're doing here make sense from the pieces we've seen before? Any questions so far? Okay, I assume that means no questions. I'm sitting here looking at this. I'm going to make a slight change here. Anybody that's had the networking class probably going to recognize this change. So our first and second number, I'm going to not do random. That was just too far from accurate for me. We have some specific IP addresses we can use. Nope. If I pull up the address for my machine here, you'll notice it starts with 192.168. There are some very particular things. So yeah, having that as a completely random number seemed a bit much. So certain addresses are reserved. If it starts with 192.168, that's your local router. 192.168.0.1 is always the router you're connected to. Another one, if I wanted to access something on this machine, 127.0.0.1 is this machine, which isn't running. Let me start up my fake server. Start Apache, yeah. There we go. So now, give it a couple seconds to start up. So now, if I type in 127.0.0.1, I'm referring to my own machine. So that's the local host.
No way.
Is that why my Plex is on that as well? Like the 127.0.0.1?
127.0.0.1 is always that's a reserved address for your local machine.
Okay, cool.
And 192.168 is always your local router. Those are reserved. So that's why I decided to, well, every one of these is going to be an office. Every one of those offices is going to have a router. So these machines really need to go off that router. It was a little bit too random, and I think some people might have already had the networking class, or when you get to your netty class, you'll be like, wait a second, we just use random addresses there. So they're not completely random. Some will use reserved ones. So every one of our offices is going to be connected to the local router. We'll bypass the switch and just, none of our offices are going to say none of our offices for this small company are big enough. We need a switch. We can do everything from the router. So all of our IP addresses will start with like that one I just pulled up here. When I look for my own address, the machine I'm on, I can access it by saying 192.168.1.5 or 192.168.1.1. My router has more than one configuration. So I have .0.1 and .1.1 on my router. Multiple, my router thinks it's more than one machine. But in general, 192, if the address starts with 192 and 168, it will that is the address assigned from your local router. And you can check that on your machines if you look at your local addresses, or you may have seen this before. If you need to access your router, your configuration protocols, you always go to a browser and type 192.168.1.1. Oh, .0.1. 168.0.1. I can't seem to type. One, not tick mark. It's taking a long time to find it.
Yeah, my AC 1750 168.0.1.
Yeah, it's taking a long time, but whenever you need to access your router, that's how you get to it. I don't know why you can't find it. It's probably because of other stuff going on. So when we go to a browser and look for different websites, it's really that number. That's how we access other machines, how everything connects together. So we'll generate a random number just connected to the local router in that office and write that to a file. So once we have it, we'll output that to the file. So we want.
How do we add the dot operators? Oh, never mind.
Just
You
with
were just
string
doing
concatenation.
it.
Because then we'll pass it on as a string, and then the computer will figure out how to add what to do with those.
Okay.
A second. That was a great question. A perfectly timed question as well.
Yeah, I was like, as soon as it was coming out of my mouth, I saw what you were typing. I was like, oh, well.
Yeah, so we'll just concatenate a big string, and then when we pass that in elsewhere, the computer will know what to do with those values once it gets them. So kind of a lot there. I might have to zoom out a little to point at all of it. So we, like on the board, we get the name of the site and the number of machines, and then we'll create a text file with the name, the user, the IT guy that we're making this software for gave it, said to call it. And then we'll just loop through the number of times so that each machine gets an address. And since completely random is just too unrealistic, I know some of you all have had netting classes before, and all of you all have to take a netting class at some point. So we might as well at least do the accurate, we'll assign all the machines to the local router and say all of our offices are small enough that one router can handle it. So now I need to go over here and clean out all sorts of stuff. Let's see, that's for this evening. That's the one we're working on. Oh, and the backups, that's a remnant from how Raptor was built in the 1990s when computers would crash a lot more than they do anymore.
It saved my butt one time, and that was enough. That was
a couple times
wrote a
people
file one
have
time.
accidentally submitted the backups, and be careful with that because the backups might, I'll keep that one around. The backups might not have the last step or two, right? If the backup didn't catch the very last step when the very last time you hit save, and it was still a minute or two before that automatic backup thing ran, it might be missing a step when you go to submit that. So be careful with those. Make sure you submit the .rat files. All right, so let's run this and see if that worked. I was talking the whole time, so there's a good chance a typo happened. Typos happen when just typing. So we should be able to check config.
I did notice one. I think you'll see it.
Oh yeah, typos happen, and I was talking and typing. So enter the name of the site. So maybe our first site is at Sellersburg. This is a class running out of the Sellersburg campus. Let's say 7 computers, maybe like 3 computers, a printer, and a couple other ports in case we need more stuff. So we generate some random numbers. Oh, is that the one you were talking about?
Yeah.
I did hit a typo. Fix the typos. So our variable is called number of machines. We want to take that, decrease that by 1, and then put it right back in the same spot of memory. So a slightly smaller number gets stored there every time. Give that a get, try again. And yeah, that's the general process, but y'all have seen that a few times by now, right? Put together what you think will work, fix the errors you made along the way, and then try that again. Oh, before I do this,
It worked.
Create the file. Oh, notice that it created that file. Let me delete. There's no file called Sellersburg. So our first site will be Sellersburg. How many computers? So again, 7. I start doing some random numbers. Oh, I hit that output line, but you see nothing's in the console. Again, another output, and nothing happened. I could probably turn this speed up a little. I don't want to go all the way up, but obviously we could turn the speed all the way up and it would go through really quick, but still kind of watching it and see our values changing. Oh, so it must have finished. Well, that was all to do for now. So exit to finish the program. And hopefully y'all are excited to see that, something that's starting to seem like a finished program. And what's more, we have this new text file over here called Sellersburg that has a bunch of IP addresses. Might not hurt to write that name in there. We can come back and adjust it, but we have a bunch of addresses, so there's only one more branch through our flow chart. Might have to zoom way out. Yeah, so we have what to do if the user's finished. Our main loop just keeps coming back around. If they want something to do, they can either configure a new site, or, well, if they give us bad input, but we still need that option. What do we do to look at a site? And there's some planning things for that on the board. If the user wants to view a site, we'll go to storage and loop through, grab the file, loop all the way through the file, and output the stuff to the console, back the regular software output. So we're reading that data back. So to go to the file is fairly easy. We can just say redirect input. And if we say yes, well, Raptor will give us that nice little normal Windows browse box. So we can browse to the file and open the one we want. And that's why we gave them all the name of the site, like Sellersburg, New Albany, whichever one it is. You can browse to it. And I'm going to go not quite in order. The computer needs stuff in a final order, right? It has to be in a certain order for the computer, but the order the computer needs it in isn't necessarily the order I think about it in, right? We think different than computers process. And it's critical that if we open a file, we close it. So often it's a good idea to go ahead and do that immediately. So redirect output, yes, then close that redirect output or input, and then do the stuff in between. So jumping around is actually more productive as we put these things together. Jump around and do it in the order you think about it in, but just make sure it's in the right order for the computer at the end. Then we saw earlier, we have a special condition on our loop, end of input. So we'll start reading a file, and then we'll loop around and around and around and around till we get to the end of that file, and then we'll exit. And each time through, basically we just need to output stuff. Is that all I wanted to do there? Oh, we have to grab the thing from the file. We redirected the input, so we need an input first. And well, we saw this earlier, the computer doesn't need prompted. We already told the computer what to do. The computer knows that if it's redirected to input from a file, that the next input is the next line in the file. So it doesn't need a prompt, but it does need a place to put it. I'll call it machine. And then we can just output the machine. We'll output what that number is. That's all we need to do to read back from the file, right? And you see how it only uses those pieces that we've seen. We've seen the little pieces, so we're just putting them together. Some pre-call things, clear out all the junk in the console. And we saw loops, inputs and assignments are combined here. But we had some assignments as well. Oh yeah, we had assignments over here, have selection structures and loops. And we've seen all of the pieces that software is built up from. So what, 3 weeks left in the class, 3.5 weeks left in the class, and we've seen all the pieces. We've seen all the pieces we need to build up from. And obviously this gets expanded in refinements and stuff, but now we're ready to get into the details and start looking at examples and doing things. There's probably a detail to get to here in a second on this of cleaning it up. Well, we already tested config, so now let's test that view branch. All right, so took the right branch. We only have one file, that one we just created to test the last one. So I'll select that. Goes through and is reading those lines and printing them back out. So I'll go ahead and exit. There's one thing I'm noticing is that output's not very clear, right? It listed out the stuff in the file, but we could probably do a little bit better as far as labeling that. For one, if we asked for more than one site and just had a big list of these numbers, it might get a little confusing. So all the pieces worked. Now we're into the cleanup stage. Which, yeah, it looks like we went longer than 45 minutes here. So the time estimate's going to need adjusted, but we get better at estimating that by making a prediction and then afterwards evaluating how close we were to our prediction. So to help keep this organized, it'd be nice if the name of that file site was there. So when we write the file, I'm going to add that in. So we had the site name. And our output is redirected to the file. So the first thing I'm going to do over in this branch is I'm going to write site name. That way, when we read back from the file, is that the best way to do that? Actually, I'll put a better label. I'll put a full label there. I'll say site and then site name. Whoops. Let me clear that out and try that again. I'll put a label by it and say what site we're at, and then concatenate on site name. So that way the file says where it's at. And then when we go to read these, we can add that an output to say what machines we have. So just a couple labels to clear this up. Let's run through and see if those is a big list of numbers, especially if we have multiple sites, can be a little confusing. Oh, wait, this label might be a problem. Oh, this label is going to be in the wrong spot, but we'll fix that. So we'll configure site. I'll just redo the Sellersburg one for now. Make sure that works and say there's 7 computers. It'll run through and got the speed turned down a little bit so we can kind of watch the flow of it. Obviously, we could make that a little bit faster by turning up the speed, or you can make it really fast by just generating an executable, and then it'll run at the full speed at your normal machine speed. So now that we have a site, well, it should have created one. Should be able to view a site. Oops, I did not mean to actually. Something went wrong. Let me stop this. I apparently accidentally generated some stuff. If you come up here and generate a standalone executable, it will just run at the full speed of the machine if you need your stuff to run quicker. So I think we created a site. So I want to view a site. Come over here, select the Sellersburg site. Machines. And then the very first time that label got a little off. Exit. So this label will be helpful, but this label should really be afterwards. Yeah, and there's something we haven't seen yet, so we'd have to get into a new topic. So I'm going to take off that machine label and just add this. Actually, I could put something small that will be useful over here. So does that make sense? Like we say, site is Sellersburg, and then the next line we say have this label says machines, and then we list out all our IP addresses. So over here where we write that first line, we could add that other label in, plus machines, and list those out. But that's going to write it on one line, right? I'm trying to speed up. So config a site for Sellersburg, 7 computers, so it rewrites it. And now when we go to view that, it kind of worked, but it gave it to us in a strange spot, right? There should be a line break there. And let's see if this works. So, and a lot of times we have with those escape sequences, like we talked about, \n is a new line in our file. I don't think that's going to work here because of the language this is written in. Let's see if it crashes. Oh, that did work. But it actually put the \n there. That's not quite what I was wanting. So over here where we write that to the file, I'll cut it out of there. And notice down here, when we write the output, there's that checkbox to end the line or just add stuff to the same line. So if that's checked, then we get a line break and we can bring in another output. And notice now it's like, okay, it seemed like stuff was working. So if we just add in some little refinements, make some nice labeling things here, make it look a little bit better. And again, a lot of back and forth, retesting things, making sure it works. That's our general process. Sellersburg, 7 computers. If we go to view those, then we get some labels there that are quite useful. Make it a little bit clearer, because if we want to do more than one thing now, we can we'll have it clearly labeled what site we're at and all of that stuff. So just little refinements. That's the sort of thing, our general process. We come up with a plan, what we're going to do, start putting it together, working in, maybe work out a few of the details that weren't quite together when we did our overall plan, and then start adding in details to clean it up, like labels and a lot of cleanup work to make it look a little bit nicer. So it seems like it works. Let's go ahead and give this a thorough test. And yeah, notice that it just wrote that right in the same folder we're at. That'll be important before long. So for a thorough test, I guess the first thing, maybe check some bad input. User gives us some bad input. Oh, we get invalid input. I meant to turn that down though. Stop this run. Let's turn it down to a speed we can watch it run. And try that again. So first thing, we'll check some bad input. Goes through here. Oh, it's not one of our choices. We throw up a message and comes back around. We're ready to do more stuff. Let's configure a site. We have that one we just tested. The Sellersburg site works. So maybe there's another branch over in New Albany. I'm using the names of towns here close to our campus, the Sellersburg campus. So some of y'all that might be from elsewhere in the state, because the virtual classes are nice from that, for that, right? If we're just going to log into a Zoom call, we can do that from anywhere. One of the people in my in the game development class this evening is in Montana right now, and he's going to be in Montana for this entire semester, but it's no problem whatsoever. So that is a really nice advantage of some of the newer formats. So I gave it a name. How many computers are there? Oh, maybe this one's a little bit bigger. Maybe that's like the big office. So we'll say 14 machines there that need addresses. It's going to run through and just keep generating a bunch of machines. I guess I can turn this up. It gets back around. Maybe another site. Maybe there's something. Maybe there's one in Charlestown with. Oh, oops. That wasn't where that went. I need to configure a new site for the Charlestown site, which has 4 computers. It's just a small branch. Somebody's working from home there, and they want to keep working from home, so they're just kind of tied into the work network. And loops through, does all that, eventually gets out, comes back around. You can see that feel of a finished piece of software, right? Not fancy graphics or anything, but it keeps running until we're done doing stuff. So now we can look at that site. So let's open up the Sellersburg site. Loops through, grabs a line, comes back around, keeps grabbing the line. Goes through and grabs all of them. And eventually, I think this time, it hits that end of file, which is our exit condition, so it leaves the loop. Let's view another site. We're in New Albany this time. Tried a bunch of machines, so I'm going to turn it up, turn the speed up. Loops through there and eventually gets to the end, comes back around. Our software is still running, even though it finished doing that thing. Everything up to this point, when it finished doing its thing, it was the end of the program. We'd have to run it again, but now hopefully it's starting to feel like a more finished piece of software. So that got all our list. Go ahead and exit and shut down gracefully. And you can see a whole bunch of addresses. Obviously, there's some other things that could be cleaned up there. We didn't do anything to check for duplicates, right? We wouldn't want 2 machines to have the same address. So that would be an important check in something like this. Pretty much any software you use on your network already has things like this kind of built in and included. So it is a very common piece of software to need, but sort of a big step up from what we've been doing before, right? We've seen all our pieces. So now we're at the point that our flowcharts get really big. We have to zoom all the way out to where we can't read it anymore to see it. Let me do this. File, print. I'll just make a PDF of this and attach that to the chat room. Where's chat room? Add a file. Okay, so over in the chat room is a PDF of this. I guess I could have opened that and looked at it. The actual picture of the flowchart. Just one thing Raptor can be useful for is you can draw nice looking flowcharts that you know for certain there are no errors in, because it kind of runs through like code. Raptor Flowgorithm. There's a really nice Italian. The nicest flowchart interpreter is an Italian product, but they haven't translated it to any languages, so it's kind of only good if you speak Italian. I can't read the menus and stuff in it, but even without being able to read the messages, I can tell it's much nicer than any of the other ones. Hopefully they'll translate that into English at some point. So I'll put that in the chat room, a picture of the flow chart, if you to kind of go through there. But does anybody have any questions about that? You see how those pieces go together? And we only have a couple of pieces that we work with, but when we put them together in different orders, we can solve any problem. And that's the idea behind software development and what we're looking at in this class, building algorithms to solve problems. The steps we have to feed into a machine in order to solve this particular problem. So kind of our first finished example, it seems like a complete thing. What do we have? So there's an hour and 20 minutes left in our scheduled time today. So that would definitely be my recommendation. Please use our time productively. But my recommendation is make up something small that you can make. Maybe not as big as your big project, but something that follows that lines of that, like a grade book example. That's a good one in a class, right? You add a bunch of, have a bunch of students, which would actually follow along with that one a lot. Instead of IP addresses for machines, you have a file for each student. And then in that file is a bunch of grades. You could probably take the labels off in that case. And then you read that back in and figure out the student's average grade from the one from those grades you saved. That would be an easy project to make, but that's my recommendation for the rest of our time today. Try to just make up a small problem, something smaller than your class project, and put that together. As always, I will be sitting here until our scheduled time. If you have any questions, can jump back on the Zoom call and address those. But hopefully, I'm always excited when this lecture rolls around. Hopefully you see why. It feels like we completed something. We actually got up to a finished product.
A whole program.
What happened?
Yeah, I'm not sure. Just kind of wrapped it up. I think finished some labels, and then since then just kind of wrapping it up.
Did it kick me out?
I guess so. You must
It
have
did
lost
for me
your
earlier,
connection
too.
somewhere.
Was there problems with everyone else's?
Mm-mm.
Okay.
Oh, well, one other person, but when she had her camera on, I think she was at campus as well.
Okay.
Is anybody else sitting at the Sellersburg campus?
I'm not sitting at Sellersburg
I
campus. My
am.
cell phone gave out though, and I switched to my PC, and that's where I came in and came out.
Okay.
Might be the weather.
Yeah, because one of the Hannah's, her video popped on earlier, and she was at campus, and she got kicked off. She left it. She disappeared at the same time you did.
Really?
So there might have
Or
just been a quick flash up at campus or something. But either way, it's been recorded now. So yeah.
Well, that was a good time to end it. So
Yeah, like Tyler just mentioned, yeah, we just did some wrap up. There was a little bit of cleanup. You might have missed the end of like adding labels and stuff, but I think you caught the gist of it. Oh, in the chat room, Keegan, I printed that out as a PDF so you can follow along. But we have some time left on our schedule. Call that lab time. Please use it productively. I suggest making up a small problem. A grade book example would follow that a lot, right? Give each student a file and then fill that file with scores so that you can find the average from the scores in that file. It would be very, very similar to that and be good practice. But yeah, finally up to the point that it's seems like a finished piece of software. It runs until the user's finished. So that was what I had in mind for today. Does anybody have any questions before we wrap up here?
Oh, could you give me a link to that
Nope.
born again shell for Windows?
Yes, I will show you that as soon as we stop
In the recording. Oh, okay.
By the way,
Yeah.
have a good day, everybody.
All right, y'all otherwise, I assume there's no questions, so y'all have a great evening. If you have any, let me know.
Bye.
And Please use the rest of our time productively. I will see you on Wednesday.